Welcome to Linear Algebra Foundations to Frontiers, or LAFF as we like to call it. We're going to start by giving you a little bit of an idea of what this course is all about and answer a few frequently asked questions. This course is not only designed to teach the standard topics in a typical linear algebra course, but also investigates how to translate theory into algorithms. Like typical linear algebra courses, we will often start studying operations with small matrices. In practice, however, one often wants to perform operations with large matrices, so we generalize the techniques to formulate practical algorithms and their implementations. To understand how to create software for solving matrix problems, we must thoroughly understand the underlying theory of linear algebra. Upon completion, you will grasp basic linear algebra concepts and get a glimpse of cutting-edge research on the development of high-performance linear algebra libraries, which are used throughout computational science.
What is LAFF?
LAFF is an online course on linear algebra that mirrors an undergraduate course I teach here at the University of Texas.
Why is linear algebra important?
Linear algebra is generally considered as important a tool for the sciences as is calculus. There is an interesting post on reddit.com that started with the question, what is the point of linear algebra? It has generated a flood of comments and is worth looking into.
What level does LAFF target?
At a typical university, a number of different linear algebra courses are often offered. There is an introductory linear algebra course, then there is often a linear algebra course and its applications, and then there is a course on numerical linear algebra. LAFF corresponds to the first course. It is an introductory course that prepares you for these subsequent courses. We added optional enrichments to also explore some of the frontiers of the subject.
Who's the audience for LAFF?
Judging by who completed the course last year, LAFF has a broad audience. Participants included novice high school students, as well as PhDs with decades of experience and every level of education in between. You may want to check reviews from former participants on Course Talk.
How will I learn?
Through short videos, exercises, visualizations, and programming assignments, you will study standard topics in introductory linear algebra courses. However, some believe that the gold nuggets are really in the enrichments.
What will I learn?
Linear algebra deals with functions of many variables. These many variables are viewed as vectors of numbers. Thus, we start by discussing vectors. The functions we focus on have special properties. They are linear transformations, which are extensions of the linear functions you studied in high school algebra. In week 2, we define linear transformations as well as investigate and prove properties of these functions. This then allows us to link linear transformations to their representations as matrices. Next, you will discover why multiplying a matrix times a vector or times a matrix is defined the way you may have been taught in high school. The reason comes from how matrices represent linear transformations. In the first third of the course, you will also learn how to slice and dice matrices into pieces. This extends your concrete knowledge about operations with small matrices to operations with matrices of any size. Solving systems of linear equations is a core topic in linear algebra. By the time you encounter this topic, in week 6, you will be very comfortable with linear transformations, matrices, and vectors. You build on this as you discover practical algorithms for finding solutions. In the remainder of the course, you study how to solve linear systems with more or fewer equations than unknowns, and find that there may be one, many, or no solutions. If there is no solution, what is the best approximate solution? The course wraps up with eigenvalues and eigenvectors. All along, you not only learn what, the method, but also why, the theory behind the method.
Do we need to know how to program, or will we learn how to program?
This is not a course that focuses on teaching you how to program in MATLAB or any other programming language. We teach you just enough about how to program with MScript, which is the language that MATLAB uses, to support what we want you to learn about linear algebra. We link abstractions in mathematics to abstractions in code. That is not the same as teaching you how to program.
Will we see applications?
LAFF tries to give you the background so that you can understand how linear algebra is applied to applications. However, that does not mean that we focus on the applications themselves. We do use a few simple examples of applications to help motivate the mathematics that's behind linear algebra. We will point you to applications of linear algebra in some of the enrichments. We also encourage you to share applications that have caught your interest on the discussion boards. This spring there are a number of other MOOCs that focus on the application of linear algebra, and you may want to look at those while you're also pursuing our course. Hopefully this will give you a little bit of an idea of what this course is all about.